Hello everyone. Transformations of exponential functions. In red we have the general form of an exponential function with the a value, the k value, the d value, and the c value, which will cause our transformation effects. Base b to the exponent x is the parent, and these transformation values get multiplied and added or subtracted to the parent function, causing the transformations. So let's look at our first example. We have g at x equals base a quarter to the exponent x is the parent, but in g at x we have a negative 1 being multiplied by the bracket, we have a negative 1 being multiplied by the exponent, and we have a plus 3 constant being added. So these form the basis of our values, our attributes that cause transformations onto the parent. So the a value is the negative 1 being multiplied by the bracket, which causes a vertical reflection. The k value is the negative 1 being multiplied by the exponent, which causes a horizontal reflection. There's no constant in the exponent, so therefore d is 0. And the outside constant is plus 3, which is the c value, which causes a vertical translation or a slide of 3 units up. Okay, let's next consider the table of values for the parent function. Base 1 quarter to the exponent x, and when we sub in negative 1 for x, it equals a value of 4. The negative exponent causes the base to reciprocate with and turns the negative exponent into a positive from an earlier lesson on negative exponents, and the value is 4. When the exponent's 0, the value is 1, and when the exponent's positive 1, the value is 1 quarter. And let's look at those attributes now in the mapping rule. So the a and the c value will affect the y coordinate. A multiplied by y plus c, in this case, becomes negative y plus c, negative y plus 3. And the k value would be dividing x, and the d, adding 0 is not going to change any values. So we ended up having x divided by negative 1, which becomes negative x. And if we put this into g at x, that'll allow us to map the parent table of values. Using this mapping rule will give us g at x's table of values. So we're mapping each coordinate. So the x values get multiplied by a negative, so the first negative 1 becomes positive 1, 0 remains 0, and positive 1 becomes negative 1. And we have our x column for g at x. Then the y column for g at x is negative y plus 3. So we take each y value, 4, 1, and a quarter, and we add 3 to it. We multiply by negative 1 first, and then we add 3. And we end up with our new table of values, which is 1, comma, negative 1, 0, comma, 2, and negative 1, comma, 2 and 3 quarters. And if we plot all that information, the parent and the g at x transformation, transformed exponential, all on the same grid, the black curve is our parent function, which has a base of a quarter, so it's decaying, it's decreasing to the right. We had a horizontal reflection, then we had a vertical reflection, and then the curve translated up 3 units. So you can see the red curve with the mapping rule, the 3 red points that are plotted. The black points were mapped to the red points, and the new curve is easily drawn. So transformations, like with any function, using the mapping rule simplifies the process. You have the key points for the parent function that you apply the mapping rule to based on the a, k, d, and c values. This in turn creates a new table of values for you, which is the transform table. and plotting both on the same grid allows you to see the transformations. Okay, let's look at our next example here. H at x equals a parent function of base 5 over 4 to the exponent x that has a 2 being multiplied by the brackets and a constant of 3 being added outside of the parent function. So those take on our a values. So a equals 2. The exponent has no multiplying effect or additional constant, so that therefore k is 1 and d is 0. And the constant on the outside of the exponential, the plus 3, is our c value of 3. Okay, let's consider the parent table of values. So we sub in -1, that reciprocates our base and turns the exponent positive, leaving us with 4/5. We sub in 0 for the exponent, that leads to a value of 1, and we sub in 1, that leads to a value of 5 over 4. Then we transform these points, these coordinates, using the mapping rule, and the x coordinate is not altered. Times 1 plus 0 doesn't change x. The y coordinate is altered, times 2 plus 3, and each value is substituted into that mapping rule, and you can see both tables here. So -1, 4 and 3/5 is our first ordered pair, 0, 5, and 1, 5.5, which will now put on the same grid and will look like follows. The black curve is the parent, and something we never mentioned in the first example, the exponential functions have a horizontal asymptote, which is the c value. So for the parent function, c equals 0, and our horizontal asymptote is y equals 0. And for the transformed function, h at x, c had a value of 3, which caused the vertical translation up 3 units. So the entire curve moves up 3 units, as well as the horizontal asymptote moves up 3 units. And the shortcut is the observation that c equals 3, means that our y equals 3 will be the equation of the horizontal asymptote, illustrated on the curve as well. And if you're following along in the textbook, 9D was the question where we came up with this h at x function, and it matches graph I. Thank you for watching. That concludes this video on transformations of exponential functions. Thank you. Have a good night. Have a great day. You guys are awesome.